In this video, you will learn how to use cylindrical periodic boundaries and how this feature can significantly reduce your simulation runtime. This tool is especially useful for rotational or symmetrical systems, such as silos, mixing drums, or tanks, where the same behavior is repeated around a central axis. Instead of modeling the full 360 degrees, you can work with a representative area, which reduces computational cost while maintaining realistic system behavior. You can define an angle between two boundaries and transfer bulk material from one side to the other. For this example, most of the simulation setup has been done in the creator. The bulk material is defined using a dual particle, and the equipment geometry has been imported, including a factory geometry to generate the particles. Under the physics section, we're using the default contact model in EDEM. Once your simulation is set up, you can define the cylindrical periodic boundaries under the environment section. There are two types of periodic boundaries available: linear and cylindrical boundaries. In this case, we're interested in the cylindrical option. Next, you can select the boundary plane using either a rotational axis or a vector. In some cases, like in this example, the rotational axis option appears grayed out, and that's because no rotational kinematic has been defined yet. Once a rotational motion is applied to the geometry, the option becomes available. In this example, the angle between the boundaries is set to 180 degrees. This allows particles to exit through one boundary plane and reappear on the other plane. Finally, to support 180-degree boundaries, the option Enable Self-Contacts and Double Mirroring was introduced. This feature is supported when using the GPU CUDA solver. If you are using the CPU solver, please refer to the EDEM documentation. Next, configure the simulator settings, including the time step, total simulation runtime, and the solver engine. In most cases, the GPU solver is faster and has become the preferred choice. However, if you're using the CPU engine, please note that it's limited to a maximum angle of 150 degrees. As you can see, we're generating only half of the material, and by doing so, you can achieve results that accurately represent the full system, while speeding up your simulation. When simulating a rotating impeller, ensure to define a cylindrical boundary angle that accurately represents the full system. In this example, we have a 4-blade mixer and we are using a 180-degree angle, which provides an accurate representation of our entire system.